Good morning, one and all. My name is ASI Siddharth, our roll number 24 BQ190408. I am going to give a seminar on topic Hilbert transform. So, what is Hilbert transform? The Hilbert transform is a fundamental tool in signal processing and analytical mathematics. It provides a way to create a complex valued signal from a real valued one by introducing a phase shift of 90 degrees or pi by 2 in radians. Here's an overview of what it is and how it's used. So Hilbert transform is a certain transform which transforms a signal by introducing a phase shift of 90 degrees. So this is the definition and basic formula of Hilbert transform. The, the Hilbert transform of a real signal x of t is defined as, so we represent Hilbert transform of x of t with x cap of t or h of x of t, which is equal to 1 by pi integral minus infinity to infinity x of tau by t minus tau d tau, where PV denotes nothing but Cauchy principal value. So, Hilbert transform produces a signal x cap of t that is 90-degree phase shifted version of x of t, as we have seen in the definition. Hilbert transforms our equation by phase shift of 90 degrees. So these are some key properties of Hilbert transform. The first property is phase shift. Every frequency every frequency component of x of t uh, every frequency component of x of t is shifted by 90 degrees for positive frequency and plus 90 degrees for negative frequency. Magnitude. The Hilbert transform does not change or alter any change in the magnitude spectrum of x of t. So the ma- magnitude of signal before and after transform is the same. Orthogonality. X of t and x cap of t are orthogonal signals. The signal x of t and the transfer equation x cap of t are always orthogonal to each other. So these are some applications of Hilbert transform where we use in real life applications. First one is AM and FM demodulation, which is nothing but in communication system. Envelope detection, instantaneous frequency and calculation, creating quadrature signals, which are also known as IBQ signals. Signal analysis, finding analysis representation, which is in signal analysis. So this is one problem based on Hilbert transform. So we we are going to find out Hilbert transform of sine omega naught t. So we know the basic formula, that is Hilbert transform is nothing but convolution of the given signal with 1 by pi 2. This. So transform of fh of t will become fh of omega, which is nothing but uh, transfer of time domain into frequency domain, and the transform of 1 by pi t will become minus j sin omega, which we know it's Fourier transform, and f of t will become eventually f of omega, and this convolution will become into multiplication. So here in our problem, f of t or x of t is nothing but sine omega naught. Fh of omega is equal to, that is our the transform is equal to minus j sine omega into f of omega. So f of omega is nothing but Fourier transform of f of t. So the Fourier transform of sine omega naught t is this pi into j of del of omega plus omega naught minus del of omega minus omega naught. So this j and this j and this minus j after multiplication will become 1, and we will get this signal further. So this is the plot of signum omega, and this is the plot of sine. As we can see, signum omega naught, we know the graph of signum is at -1 for minus values and +1 for positive values, and this is the graph of sine omega naught, that is minus j pi of del of omega plus omega naught minus del of omega minus omega naught with amplitude pi and minus pi. So after multiplying these both signals, as we can observe, the when the positive when the positive part is multiplied with 1, it does not changes. But when the negative part is multiplied with -1, it's it's shifted towards another side of the axis. So now the equation of omega has become fh of omega is equal to minus pi. Since both amplitudes are minus pi, we will take minus pi as common. It will become minus pi del of omega plus omega naught plus del of omega minus omega naught. Now this is the equation of the signal when both signum omega and sine transform of sine gets multiplied, we will get this equation. So now to get a now to get our Hilbert transform, we have to convert this uh, frequency domain into time domain, which is nothing but inverse Fourier transform. So as we can see, after after applying inverse Fourier transform, this fh of omega becomes fh of t, and this minus pi of del of omega plus omega naught plus pi of del of omega plus omega naught plus del of omega minus omega naught is the Fourier transform of cos omega naught. So when we apply inverse, it will become cos omega naught, and since there is minus, we'll add this minus. So finally the transform of cos omega naught t has become fh of t, that is Hilbert transform of sin omega naught t is minus cos omega naught. So this is some basic introduction on Hilbert transform and also an example for Hilbert transform, which is a simple problem solving on sin omega naught t, which has resulted in minus cos omega naught. Thank you.